We're back with you, dear viewers, and it was really a wonderful report from our colleague Hadil, and she is really going there and there. Farid, have you seen all of those things? And it was Friday, the Disabled Day for all of internationally.
Absolutely. You know, it's Bobyan Club is really well known for these such events. You know, helping the community, and you know, these services always good. You know, to be like really intuitive to these events, because you know it makes you up to date and you know what's going on. And
I think because they really emerge the disabled with the ordinary people, with each and every one. Because in the past, some of the people really were apart, but now they are part of us, they are with us, and we need to see what they have in common and what they have talents.
Absolutely, and what an honor, you know, really to help such people like that. And you see, this is really, I mean, God gift, you know, to help these people in a need for that.
And they are gifted.
Absolutely.
They do, and have loads and loads of talents. And speaking of talents, we have a talented lady here in the studio with us.
Absolutely. The field of engineering is a continuous field with a new research and courses.
Absolutely. From time to time, scientists produce new methods and lessons. So how about we elaborate more with our dear guest, Dr. Zainab Al-Hajaj, Assistant Professor in Engineering Department. Hello and good morning, Zainab. And we have two engineers in the studio.
No,
good morning.
She's Assistant Professor. You know, this is amazing. And this is well experienced engineer Assistant Professor Zainab Al-Hajaj. And it's an honor to have you here in sunshine.
Thank you so much. Thank you for having me. The whole team of ASICA are really glad that we get the opportunity to show our student work. So thank you for having us this opportunity.
Zainab, Dr. Zainab, please, could you tell us about yourself, you know, because before we go deep in the questions.
Sure. I'm currently working at ACK as an assistant professor. I have a background in mechanical engineering. I work in a research in a material called composite material, which involve natural fibers. That's actually very new material, and we'd like to enforce that and actually spread their application around us.
Really? So the fibers, and I have seen you brought some fibers with you. Can you tell us a little bit about this project? Is it a learning course and engineering department? I know that, but how is fibers into that?
Sure, I'm just going to give you a little introduction. So what we do, we have a course called PBL. It stands for PBL, yes. It stands for Project-Based Learning. And it's basically the first one in Kuwait that's been implemented by engineering school. What we do is a student get to implement their skills, abilities, and the theory that they learn into a project, a practical one. So in our project, we try to use a natural fiber, and it's a collaboration between the three different departments: civil, mechanical, and electrical. I hope electronics. Okay, so we're all work together to get a solution. And it started from my colleague, Professor Mohammed Yassin, in which he thought the Kuwait is well known for actually growing the palm trees. So why we don't use the leaves of the palm tree and extract the fiber from it? If you can see here, this is actually from the leaves of the palm tree, in which it was grinded, and basically we're trying to mix it with a concrete. To improve their thermal properties, because they are more insulator, so to improve their thermal properties and use it for buildings in Kuwait.
Oh, that's amazing.
That really is amazing indeed, Farid.
Absolutely, and definitely there's a video, you know, to share with you, but this is really a new idea, as we can see on the monitor.
So now this is the mixture you're mixing.
Yes, they're mixing it with a concrete, so they prepare the final concrete with it. Students get really involved in a practical work.
It's hands-on experience. Huh?
Yes, yes it is.
And this is, he's mixing the fiber with the...
Before they prepare the concrete itself, because we're going to mix waters and additive to the, so they're trying to...
Okay, so there is more additives to, to the fiber itself.
Not to the fibers, to the
fiber,
mixture of concrete.
The mixture of the leaf or palm trees?
They're grinded, so they mix it with the mixture of the concrete itself.
Okay.
So concrete has many types of materials that mix together,
And this is here, what's this green thing?
They're trying to prepare samples to get them ready for testing, mechanical testing, because before you introduce any material, you have to make sure they really have acceptable mechanical properties. You dig around to get their specification before. So these are preparing the raw fibers. There are different types of fibers, by the way. This is called flax fiber.
And this comes from the same tree?
No, it's called, you have seen nowadays in a linen clothes, if you know.
Linen,
and you heard something called flax seeds.
Yes.
Same as like a chia seed. So we take the fibers from the stem of the plant. Rather than just waste it, we can actually use it in mixed material. That's a very recent project. We're starting up, so we haven't really got deep in it. It takes time to come up with a new material.
So this is, so you have two kinds of fibers, one from the palm trees and the other are like from flax seeds, and you get them and mix them with the concrete and do like the mold of blocks, right?
Yes.
So we have all of that. It is as waste, if anybody would say that, but you took that waste and recycled it and put it into a good use for it.
Useful.
Yeah. So why mixing natural fibers with the concrete? You said something with the, why do you put it in those concrete blocks?
Sure. I just want to say something. They are actually comes not from the seeds, they come from the stem.
Okay.
I just want people to actually remember that.
Not flax seed, flax
stem, and basically the reason why we do and you use natural fiber because they are available, they're natural resources, so it's an aim to substitute man-made material with a natural fiber. So rather than actually get them waste and burn them in the field, we can actually take advantage of it and add it to our concrete mixture. And the reason for that, they're really good insulator. So we're aiming to mix it with a concrete to our main goal is actually to reduce the consumption of energy in the building.
Okay.
And it is one of the, if you heard recently the COP26 that they're working toward the climate change. So this is basically a step toward applying this in Kuwait and work on actually efficiency building and sustainable building.
Green building.
Yes.
So what you're saying, you're trying to build some asphalt or building or bricks, you know, that environment friendly, and they don't reflect the global warming. I mean, the heat that, you know, comes from the ozone layer and stuff like that. So this is like really in that direction?
It is part of it. So what we're specifically working on is reducing the consumption of energy. So rather than people use, for example, AC or heater that can do the job. It's a part of the world actually working in the climate change. But doesn't goes like in ozone and those, but
so
more
we don't
than
go to that level. Yeah,
it is all working toward actually the same goal of working in using alternative resource.
So is it like, you know, really be more realistic? Is it really feasible? Like, I mean, sustainable? You can really, or it has a high cost to extract these fibers and these elements?
That's a good question. They are really cheap, and even they're go west. So basically, we collect those leaves without even paying for them. They're available. They're cheap.
Absolutely.
And many companies nowadays, automobile as an example, Ford and Mercedes, they're trying to replace their man-made or synthetic material by a natural fibers material, which it can reduce the cost, reduce the consumption of the fuel, increase their revenue. So it's all toward actually working and actually using those natural resources in our applications.
So let's get to that. Have you built something that I know that the students with you as a professor, assistant professor, also giving those materials are in handmade. We don't want them to go to waste. We don't want to like have a very bad carbon print upon from those buildings. Have you built something, and did you really measure it?
Our students are doing a great job. They're really getting into a lot of practical work. Our field is more like research, and when we get to the acceptable properties, we can actually introduce that to the market. Our student currently working in preparing those fibers, make them ready to be used, preparing samples to be used under testing, different kind of mechanical testing, thermal testing. As you saw in the report, they're really doing a great job for testing, preparing the sample to test it. And we're proud of our students. A lot of our students or engineering students, they complain that when they get into the working field or industry, they don't really have that experience. So we're trying to, in this program, the PBL, we're trying to prepare them to the industry. We're trying to implement their knowledge and get them test that experience. So when they graduate, they really have a good...
This will be like a second nature.
A good engineering experience that will, and hands-on experience that prepare them for the field. So we're really glad about what they're working, and we're still working on that. So it's an ongoing research.
Nice.
Well, you see, they are getting their hands dirty now in the college. Instead of saying, we didn't know how to do that, we didn't know how to build that, or how to put, etc.
But I have a question.
Yes.
Because you know the average viewer to know, what's the benefits in the building, for the buildings in Kuwait, for that material, if it's mixed with the bricks or whatever?
We know here in Kuwait it's a hot climate, so we have a high increase in usage of the AC and energy. So it's a part of actually towarding implement this in the building and reducing the consumption of those energies, most like.
So it's like an insulator, the temperature?
Yes, yes. In other buildings, I know in France, but it's not very popular, that they use the flux as a sheet or as a plate. Sorry, a flat plate to put in between the walls as an insulator. We're investigating actually to mix this with the concrete itself and come up with the idea, a material with the properties that can be compared to the other.
The bricks.
Yes.
There is something similar to that, but in the nanotechnology. It's like, the brick itself. It changes every season.
Phase change material with
exactly. And this is like, it acts like an insulator, and also it acts like the other way around, the opposite, when winter comes and stuff like that. But it's really a good step in that move.
Thank you.
Congratulations. This is really amazing.
It is amazing. And we have seen a little bit of the photos, that how the students are really getting into work and seeing and measuring and grounding. So this takes us to you have 3 categories of engineers, you said. They are mechanical,
civil,
I guess,
and electrical.
They are all together working in the PBL. So
yes.
How does the electrical really benefit from that?
We're working, so introducing this material, we want to actually deeply characterize it. And there is many type of characterization, like civil could get involved, mechanical, and electrical. What I remember, our colleague from the electrical department, they're involved, we're testing those concrete if they're able to withstand the hit and the impact. So they were working on applying a sensor to see how much it could reflect, and does it really affect if it has no fibers or not. Because we see so much incident in Kuwait in which bridges actually, when they get hit, they quickly break or crack. So maybe this could affect it. So the electrical department are really characterized in applying those sensors and see the reflection, deflection that it could create it by those material. It's a deeply characterized, so before we introduce a material, we really have to make sure that we covered majority of the aspect to market our product.
That's true, because
they're covering our bases.
Yeah, absolutely. This is nowadays sensors are involved in everything. You're right. You're correct. They see how what are the elasticity of the brick, you know, how it sustain its, you know, rigidity and, you know, stuff like that. But I mean, let's move on to another aspect of this project. Are you getting any support? Is there any sponsors? I mean, because this is really something, a good project. You know, we're talking about Al-Matla, 30,000 unit people gonna build. You know, in Al-Matla city.
Yes,
you
and
know,
this is really, if it's done and it really gets to those buildings,
absolutely.
You know how much electricity it would be down, because they would really save from heaters as well as coolers.
Thank you for asking me this question. So we really appreciate KFAS, Kuwait Foundation of Advancement of Sciences. They annually actually put a budget for researcher to apply, and they specify majors, like for example for energy, for climate change, they specify that, and we get a support financially from them. We appreciate that, because without their support we probably going to have a very limited ability to do this work. We're also thankful for KFAS, ACK for providing this environment for students and get them involved. We would love to prepare our engineer student for that. And also we thank the PUC for the continuous financial support to our students. Yeah, so this is really encourage us to keep going in our research.
That's really marvelous. So you have like a lot of collaboration with you from KFAS, from the municipalities as well. Does the municipality really comes with you? And how about other universities?
Sorry, other university in which term?
Any cooperation?
Cooperation. We are.
I mean, sometimes, you know, you have these ties, you know, with other universities, other. I mean, people are smart in that and well experienced in that. You know,
especially
especially
the engineering of Kuwait University.
Yeah. Right. Thank you for bringing back this question. Correct. We're working on one of the examples. We're working on Ryerson University, Ontario, Canada. There's a professor. Would like to mention his name, Professor Ziad Saghir. We're working, collaborating, and one of those material that we're working on is the phase change material.
Okay.
We're doing some.
Engineer talk. Engineers talk. This is engineers talk.
Absolutely, that's amazing. It's, you know, Canada also famous for that, and especially Canadian universities are really high-level universities. Really, we are almost done. But if you have any message you want to address your viewers.
Or students.
Oh, sure.
Students, yeah.
Sure. For people who would like to actually get into engineering school, I would recommend them actually to come and register in our ACK university. You're really going to get so much practical work. A lot of students really, they loved, they're probably like not doing very well in theory, but they will find it very interesting to work on ongoing projects. They're getting them ready for the industry. Not only this, if they want to complete their master or PhD, they will have a very great experience working on this. We'll be very glad actually to have a student and graduate and make them graduate in this course with a good knowledge that would prepare them to the market.
And also, I heard you have like 2+2 in ACK, is that right?
Oh yeah, correct. See, he's more experienced. Yes, correct. Yes. So they actually can get into getting their diploma, and if they're willing to leave without getting their undergrad or bachelor, they can get a certificate and go with it. And if actually they want to come back in any time, they feel like they want to continue with their study, they can come back and they will have another degree, which is the bachelor degree.
So you have the option of diploma and degree. So,
yes, so this is like living the two good lives. You can really go there, have your diploma, work a little bit, or go like vacationing, and then after that, if you want to take your bachelor's, right away get back to the ACK. Thank you very much, Dr. Zainab, for being here and sharing such a marvelous project, as well as beneficial for the students and the environment of Kuwait. We really hope those things would happen soon enough, because as my colleague Farid said, we've got more than 30,000 blocks to be built, so these would really help.
Thank you very much, Dr. Zainab Al-Hajaj. Appreciate it. And dear viewers,